Hey everybody, Morgan here. We're talking about electrochemistry again. We are on page 7 of our lecture outline, and this is going to be talking about the relationship between EMF, or the voltage associated with a chemical reaction, and free energy. So I want to bring your attention back to page number 4. And at the bottom of that page, we talked about a spontaneous reaction having a KEQ, which was larger than 1, a delta G, which was negative, and an E naught, which was positive. The KEQ greater than 1 tells you that the products are favored. That's a spontaneous reaction. The delta G naught being negative means that the free energy is available to drive the reaction. That's a spontaneous reaction. And the positive potential difference tells us that the reaction is going to happen. So, on page 7, what determines if a reaction happens? I like to say free energy. I like thermo. However, any of those three can be used to figure out whether or not the reaction is spontaneous. So, there must be a relationship amongst those three things, and that's what we're going to develop on this page. Delta G naught equals minus NF E naught. Now what we're saying here is that delta G is basically equal to E naught with a conversion factor because of the units and by multiplying by the number of moles of electrons. It turns out that delta G naught is what we call an extensive property and E naught is an intensive property. So this is per mole of electron, so we need to have that in there, okay? All right, what look like degree signs here, naught, are telling us that this is happening under standard conditions, 25 degrees Celsius, 1.00 atmosphere pressure for anything that's a gas, 1.00 molar for anything that's a solution. We can also have non-standard conditions. Delta G equals minus NF E. Same relationship. Now, in thermo, we learned that delta G is equal to delta G naught plus RT ln Q. The non-standard free energy change is the standard free energy change plus what is essentially a correction factor. Okay? Now what we're going to do is we're going to plug these into this. But before we do, a little mathematical thing that's not all that common for you today because of calculators. But in my freshman chemistry textbook, delta G equals delta G naught plus 2.303 RT log Q, the natural log rather than, the common log rather than the natural log. So to convert natural logs to common logs, we multiply by 2.303. Turns out when you did these on slide rules, it was easier to do a common log on a slide rule than a natural log. Okay, so a guy named Walter Nernst did a lot of electrochemistry stuff in the early 1900s and started to develop these ideas. And we have named an equation after him, which is basically us taking this equation and plugging these two in. So delta G is minus NFE, non-standard, which equals minus NFE naught, standard conditions, plus, now, most of the time it's RT ln of Q, using the natural log. So, to start to get this into a more useful form, E and E naught, we will divide the entire thing by minus NF. So over here it's going to cancel, and there it'll cancel. It won't cancel here. So E equals E naught plus RT over NF ln Q. And Nernst said most of the time we're doing this at 25 degrees, and we know what R is. It's a constant. And came up with E equals E naught. And in this case, okay, minus 0.059 over n times the common log of Q, okay? And it looks like I made a little boo-boo there, that should be a minus sign, not a positive. Sorry about that, okay? All right, so this is a very useful tool. If we're looking for equilibrium constants, we also can remember that delta G naught equaled minus RT ln K, which is also equal to minus NF E naught. And some algebra will show us that the ln of K equals N E naught over 0.025693. Now, very often it's expressed as the common log. Log K equals N E naught over 0.0592. Okay, that's assuming 25 degrees Celsius, but since these are standard, that is implied. Okay, so some very useful equations here. This one, right there. Now, just a little reminder, volts is equal to a joule per a coulomb, or a joule is equal to a volt times a coulomb. Okay, so now we're going to do a couple of problems here where we calculate delta G naught and the equilibrium constant for these reactions. Now, several pages ago, we actually did a calculation for these two reactions. Okay, the Ag plus Cu2 plus and the zinc plus the nickel 2 plus, where we got 0.46 and negative 0.51 volts for both of them. Okay, so that was back, just in case you want to check, on page number 3. So we're going to use those values. So E naught equals 0.46 volts, and E naught is equal to negative 0.51 volts. So let's find delta G naught. Equals minus NF E naught, which equals minus, and in this case, 2 moles of electrons move, times 96,485 coulombs per mole of electrons. A lot of people round that off to 96,500. Moles of electrons cancels moles of electrons, times 0.46 volts. Okay, now we have a coulomb times a volt, which is going to be equal to a joule. Okay, now this ends up equaling, grab a calculator here, negative 2 times 96,485 times 0.46, and we get negative 88,766. So negative 88,766 joules, or negative 89 kilojoules if we're paying attention to sig figs. Okay? Now, let's do the equilibrium constant also. The ln of K equals 2 times 0.46 divided by 0.02563. Okay? So, 2 times 0.46 equals, divide 0.02563 equals, second e to the x, second answer, and K, well, the ln of K equaled, ln of K equaled 35.8. So K equaled 3.6 times 10 to the 15th. Now, make some points here. This was a positive EMF, spontaneous reaction. This was a negative delta G, spontaneous reaction. And this is a KEQ that's really huge, much, much greater than 1 10 to the 15th. Again, spontaneous reaction. Okay? So I'd like you to try this second one yourself. You can pause the video, then tune back in. Okay, welcome back. If things went well, delta G naught is going to come out to be positive 98,430 joules, which would be 98 kilojoules. The E naught we already said was negative 0.51 volts. That's an agreement. And KEQ comes out to be, let's do that calculation real fast here, 2 times negative 0.51 equals divided by 0.025693 equals second e to the x, second answer, about 5.7 times 10 to the negative 18th. All right, and all of this is an agreement for a non-spontaneous reaction. Okay, that's page 7, and this will be Morgan tuning out. Bye.